Now I'd like to work a little more challenging problem, one which you begin to see the process of solving by elimination. So here's a system. Solve negative 5x plus 2y equals to negative 13. X plus 6y equals to 9. And let me just give you a quick word of advice. When you're working these problems and you can't seem to get the right answer, or at least the answer in the back of the book, one of the first things you should check for is, did you copy it down correctly? So it's very easy to make copying errors in working these problems, as I have found out personally many times. So I'm in the habit of, when I copy a problem from a book or from some other source or from another page, that I double check myself to make sure I haven't miscopied. So one thing to look out for. Alright, now what are we going to do here? In the last video clip, we just simply added equations together. But if I added equations here, I would get negative 4x plus 8y equals to negative 4. And you would have to say, well, what progress have we made? Because this equation has two letters in it. And my goal is to find a specific number which for x and a specific number for y. I can only get that by eliminating one of the variables. So I look up here and I ask myself, what's the easiest variable to eliminate? And I'm probably going to pick on y, because I see that if I multiply this equation by negative 3, then I'll produce a negative 6y, which will cancel with positive 6y. You could also multiply the second equation by 5 instead, and this 5x would cancel the negative 5x. And it's probably a toss-up which one is cleaner. So I'll go ahead and go with my first choice, but you can do it either way. Alright, so watch what happens here. I'm going to multiply the top equation by negative 3. And I'll bring it down here. So this gives me 15x minus 6y equals to positive 39. And a lot of students will make the mistake of forgetting to multiply the number on the right side. Very easy to overlook that. Okay, I'm going to recopy the second equation down here. X plus 6y equals to 9. And then combine the equations by addition, and you see that the y's are eliminated. And this gives me 16x equals to 48. And so we've made progress, because by eliminating the y variable, we can now solve for x. 16x equals to 48. Divide both sides by 16. And x is exactly 3. So I'm going to circle it so I don't lose it. I small regret by not having a larger board and someone behind the camera moving the camera, because then you can see me work this more naturally. But I'll have to keep erasing in order to make room on this little board. So, but I might, people make mistakes by being disorganized on paper, and so be cognizant of that. Don't cramp your work, crowd your work, or jumble it all together where you might lose track of what you're doing. Alright, so I'm going to have to do a little erasing here. But x equals to 3 is one of my solutions, and I have to figure out what y would be. So I'm going to make a little room. And what should I do? Well, x is a solution to either of these equations. And so I want to solve for y. And let's suppose we decide to go to this equation. Alright, so I'm going to replace x with 3. 3 plus 6y equals to 9. And now I can solve for y. I think you can see y equals to 1. If I subtract 3 from both sides, 6y equals to 6. divided by 6, y equals to 1. So my solution to the problem will be, whoops, telephone, the coordinate point 3, 1. Let me get the telephone. I'm back. That was my daughter. She's on a bus 3 hours away. Okay, so, well, let's go back to work here. I've written my solution as a coordinate point 3, 1. And now I'm going to do the other very important thing, which is to check the answer. So let me go back and look at the original equations here and check our answer. Now, oops, this was, 9, wasn't it? Something important about this checking business. If you only check this solution in one equation, then you're wasting your time. Because it's very possible to make a mistake in solving that will cause your answer to be correct in one equation, but wrong in the other one, or the other ones as we get more equations. So if you're going to check, then check them both. Otherwise, probably shouldn't bother. Alright, so I'm going to check. And the first equation, again, I'm replacing x with 3 and y with 1. I've got minus 5 times 3 plus 2 times 1 equals to negative 13. That gives us negative 15 plus 2 is negative 13. And we see that's correct. And the second equation, we have 3 plus 6 times 1 equals to 9. 3 plus 6 equals to 9. That checks as well. So we can be confident that we have the correct answer. Now what if we plug those numbers in and something doesn't work? Then you've got a mistake. You need to fix the mistake. So that's about all there is to say about that.